Hey everyone, welcome back to the channel. I know it's been a long time that I have not uploaded a video, but if you are new here, I'm Nabeen, and today we're cracking one of the biggest building blocks of Python, that are operators. So, what exactly is an operator? In simple terms, operators are symbols that perform operation on values. Think of them like verbs in your code, they do things. Python actually has 7 types of operators, but don't worry. By the end of this video, you'll master the 3 most important ones that you'll use all the time. Let's dive in. First up, we have arithmetic operators. These are the ones that do the math. Let's use a simple example here. Say a is equals to 10 and b is equals to 3. And the first operation we do is addition. So simply if we add them, it should give us 13. So if you see here, we are getting a plus b equals to 13. Similarly, subtraction will give 7, simple as that. Multiplication will give us 30, simple as that. Division. Now here where it becomes interesting. So when you divide 10 by 3, you get 3.333. This is what we call a true division. That actually gives a true division quotient of that particular expression, that is 10 divided by 3. Now, what if you want only 3 and not the point or the decimal part? You don't want the decimal part, you just want the whole number. Now, there comes floor division, that is double division symbol, that is double slash. Now, it returns the floor value of the quotient. Now, what is a floor value? Now, there is some term called floor and ceil in Python. Okay, ceil in Python. Now, think of them like your house's floor and ceiling. So suppose you are something in between the space of your floor and ceiling of your house. If you want to go to the floor, you go down, you go below. If you want to go to the ceiling of your house, you go up, you above the ceiling, right? So similarly here, now what is the closest whole number to the 3.33.5, 3.33333 something. So the closest whole number lower than this is 3 and upper than this or greater than this will be 4. But this gives the floor value. That means it will give us, that's why it will give us 3. Now if we just run this, we'll get 3 as an output. Next up, we have modulus operators. So this is the final operator, this is the final arithmetic operators that we'll be using. So this is nothing but it gives a remainder of the expression. Now, for example, we take 10 modulus b. Now we know a is 10 and b is 3. So what is the remainder of 10 divided by 3? Now 3 into 3 is 9 and 10 minus 9 is 1. So the remainder should be 1. So this simply gives the remainder as output. So next up we have assignment operators. So these are all about giving values to variables. So the most common one that we use is single equal sign. You have seen here I have assigned some values to 10 and 3. So that's why it is called an assignment operator. That is assigns values to a variable. In my previous videos, I have told you that the variable is nothing but a box that can hold some value or some oranges, that per se is a value. Now, this equal sign is doing single equal sign that we call is nothing but it's putting this value in x. So if we do this, it'll simply gonna print 10. Simple as that. Now, suppose you want to add 10, add 5 to this x. So normally what you will do, you will add x to the add 5 to x and you'll assign that value again back to the x. Now you can assign to a different variable as well. Now for now I'm assigning back to x. So if you add 10, so for now x is 10 before the assignment. So it comes from right to left. So before the assignment, it is 10. After you added 5, it becomes 15 and that 15 will get assigned to x. Now it should print 15 as an output. So you can see 15 as an output. But since you are doing, you are adding something to the same value and assigning to the same value, there's a shorter way to do this. So this is called a shorthand. So you can actually do x plus equals to 5. So this is also an assignment operator that will add x, x's value to 5, and that then it will again assign to x. So these two are the same terms, just it is shorter. So if I run this, So you can see it's again 15. Okay, now our third big group is comparison operators. Now these check how two values relate to each other and always return either true or false. Now let's take an example. We again have a equals to 3, b equals to 10. Let's take the same example. And first off, we have equality operator. That is, it will check if either of the no, if both of these value are equal or not. If they are equal, it will give true, else it will give false. Now you see a is 10 and b is 3. Are they both equal? No. So this will give us false value. So if I run this, you see this gives false as an output. Now, I think I'll zoom in a little bit. Okay. Okay, now same. So this is to check if they are equal. Now this there is not equal sign. This is to check if they are not equal. Now this will return true if these both values are not equal to each other. It will return false if they are actually equal. Now a is 10, b is 3. So if we run this, what it should give? It should give true because a is not equal to b. So I'm getting true as an output. Simple as that. Now we also have two more comparison operators that are greater than or less than. So greater than and less than just work as they work in maths. So if a is greater than b, so it checks if a is actually greater than b. So if a is greater than b, it will give true, otherwise it will give false. If a is this lesser than operator, we'll use a is lesser than b. If it is less, then it will give true, otherwise false. Now here a is 10 and b is 3. So 10 is greater than b should give us true. 10 is less than b, no, that is not correct because 10 is greater than b, so this should give false. Now if we print this, you see a is greater than b gave true, a is lesser than b gave false. Now, you would have seen these all operators in most of the if statements. If you have done some exercises, you would have seen this in most of the if statements. Now, let's take a simple example of using these kind of operators. Now, we can also use greater than symbol with a equal symbol that will check inclusive of this value if they are equal. Suppose a is greater than or equal to. Now, when I say only greater than, if age is 18, 18 is not greater than 18, right? So if I give this 18, so this expression will give me false because 18 is equals to 18. 18 is not greater than 18. Okay. So, but if I give equals, it will check both. Either it is greater or equal. So if I give, now I'll give age here. So this will check either it is greater or equal. Now first it will check, is it greater? No. Yeah, age is 18, this is also 18. So it is not greater. Again it will check, is it equal? Now we know 18 is equal to 18. Yes, it is equal. So this will give true. So you can, if we run this, yeah, so you can see here we got true, and when this got true, this will be implemented, and we got yes, you can vote. So if I remove this and if I run again, so you can see here when it was actually equal, when it was equal here, this is how it got printed. Whatever inside the print only got printed because that is what needs to be done. Now when I remove that, you can see the whole thing is printed. That means it was not executed. Okay, all right, those are the big three. But before we wrap up, let's quickly mention the rest just so that you know that they exist. Okay, so the other operators that we somewhat use are logical operators. Okay, so these are nothing but gates. If you have studied in electronics, gates, electronic gates like and, or, XOR. So and, or, not, XOR. So these are the same operators. Now and what we they are used to compare two conditions here. Now suppose I give has ID is as true. Okay, this holds a true value. Now is adult, I gave a is greater than or equal to 18. Okay, so A's we have 18 already, and is A is greater than, so I told you from right to left. So age is greater than or 18. Yes, it is greater than or equal to 18. So this will also hold a true value. True value. Okay. So writing this as this or this is similar. Now we'll check if adult and has ID are both of them true. So and will only give true if both of them are true, or will give true if any one of them is true. not will just reverse, like is adult is true right now, it will just reverse it to false. If it is false, it will reverse it to true. That's it. Now let's see. So has ID 18. So let's see the first one, that is and. You see, and came true because both of them were true. Now if I make one of them false, if I make one of them false and again execute this, so you can see false is printed because one of them was false. Okay. Now let's run. Let me run this, and let's run this value. Okay, or. So or gives either of them if it is true. If this is true or this is true, anything is true means it will give true. So you can see it gives true because our is adult is true right now. So this will just reverse, as I said, is adult is true right now, it will reverse and give us false. If I make this false, if I make this false and execute this and execute this, you can see it is giving true. Okay, I hope you understand. Let's move on to the identity operators. Now, let's take a list of 1 to 3. For now, let's just think of them as sequence. It's a data type. Okay, now I make list 2, I copy the list 1 to list 2. Now these are the same object. That means whenever I assign a value like this, a list like this, the reference of this will be copied by this, the memory location of this list 1 will be copied by list 2. So that's why they both will be equal, that it will come true. If I print this, so you see it will come true. Now if I do this list 1, see, you see both of them have the same value, but since list 1 and list 3 are stored in different memory location, this will come false. So this will come false. Okay, now I'm checking list 1 is equals to list 3. Now equals operators, this is double equals operator, we should it compares the value if they're equal. Now see, list value of list 1 and value of list 3 are same. So if I run this, we'll actually get true. Sorry, yeah, what is syntax error, did I not run this? So yeah, you see here we get true because the values are equal, but the memory location is different for list 1 and list 3, but it's same for list 1 and list 2. That's how identity operator works. So there's one more operator, membership operator. It's nothing but it checks if something exists in a sequence. So apple, this is a string which is a sequence. Now I'll check if A is in this apple. So there are two operators, in and not in. So in will give true if this exists inside this sequence. It will give false if it doesn't. Not in does the reverse. It will give true if it doesn't exist, it will give false if it exists. So let's run this both. So you see A is in apple, right? So that's why it gave true. So Z, is it in apple? No. So not in also gives true. If I give A not in word, this should give false. So you see this is giving false. Now the last one are bitwise operators. So these are nothing but and or not gates, but they will perform the operation in binary level. So when you take p equals to 6 and q equals to 3, the binary of 6 is 110 and binary of 3 is 001. Now, and will perform the and operation in these binary conversion of these numbers, and then convert them back to the um, decimal number. Now, if you AND these both, so 0 and AND gives us 0, 1 and 1 will give us 1, and 1 and 0 give us 0. So that gives us 0, 1, 0. That is 2. So similarly, OR will OR. So OR is like if it is 0 and 1, if either of them is true. So 0 means false, 1 is means true, either of them is true. Yes, one of them is true. So it gives 1 here. Now again you see 1 and 1, both of them are true, so again 1. So 1 and 0, either of one is true, so 1, so we give 7. Similarly, XOR operation will give true only if both of them are different. Suppose 0 and 1 are different, that means it will give 1 as an output. 1 and 1 are same, that means the XOR will give 0 as an output. 1 and 0 are different, so it will give 1 as an output. So that gives us 101, that is 5. So similarly, there is left shift and right shift. So left shift will shift the bit by one position towards the left. So if we shift P by left shift, so it shifted. So it, see, you see here 1 1 0. So it shifted towards left side. It shifted toward this side, this side, this side. It shifted toward this side. So one more 0 needs to be added here. That's why it got added and it got 12. So 1100 is 12 in binary. Decimal, sorry, 110 in binary is 12 in decimal. So similarly for right shift, we shifted towards right. So we got there's Z- so we got 003 right shifted. P is right shifted. So 110. So this 0 got vanished. So make it three digit. We add one more 0 here. So 1 gives us 3. Okay. So a quick recap. A quick recap. Now you know arithmetic operators do math, assignment operators store values, comparison operators check conditions, and there are few more operators like identity operators, membership operators, bitwise and logical operators that you are also familiar now. So here's a quick challenge for you. Open your Python editor and try to combine all of these operators, maybe calculate your weekly allowance or check if your age is enough for a movie rating, or check if which of the three number is greater, greatest and lowest, etc. Because that's how you learn. Play around, that's how we learn. So thank you for watching. If this video helped, hit the like button, subscribe for more beginner friendly Python lessons, and I'll see you in the next one. Happy coding.